Hello everyone and welcome to this video where we will be solving questions about potential energy and potential difference. A charge of 1 multiplied by 10 to the power negative 4 coulombs was displaced 20 centimeters through a uniform electrical field. The potential difference between the plates is 20 volts. What was the potential energy needed to move this charge? And we have these following options. Okay. What are all the equations we learned about potential energy and potential difference? We know that the potential energy is equal to the charge multiplied by the electrical field multiplied by the displacement, okay? Or we can also say that the potential energy is equal to the potential difference multiplied by the charge, right? Okay, based on the inputs we have here, we have the distance, we have the charge, and we have the potential difference. Which of these equations will be more helpful? It will be, yes, this equation, because we have the potential difference and we have the charge. So we can say that the potential energy is equal to the potential difference, which was 20, multiplied by the charge, which is 1, multiplied by 10 to the power negative 4. And we will have an answer of 0.002 joules, remember, because the unit of energy is joules. If a negative charge equal to 2 microcoulombs was added at point 2, okay, so we have many points, 1, 2, 3, 4, and it was added at point 2, which is closest to the negative plate. The distance between the two plates was 10 centimeters. The potential difference between the plates was 100 volts. Find the force on the charge. Okay, so this is a little bit tricky. We have the following choices. We know that the electrical field is equal to the force divided by the charge. We learned this from the previous lesson, which was electrical fields, okay? If we do a cross multiplication right here, a simple cross multiplication, we will get that the force, which is what we want, is equal to the electrical field multiplied by the charge. We have the electrical charge. The electrical charge is equal to 2 microcoulombs, right? It's given right here. But we do not have the electrical field. But on the other hand, we have the potential difference, okay? So let's use the equation that says the potential difference is equal to the electrical field multiplied by the distance, okay? Now, we have the potential difference and we have the distance. So we can say that the electrical field right here, it's going to be the potential difference divided by the distance, okay? And we already know that the potential difference is 100 volts, and we will divide it by the distance. The distance is 10 centimeters. Be careful, do not use 10 centimeters. Remember to transform it into meters. So 10 centimeters is equal to 0.1 meters. Divided by 0.1, this will be equal to 1,000. Now we can go back to our equation right here. We can say that the force is equal to the electrical field, which is 1,000, multiplied by the electrical charge, which is 2, multiplied by 10 to the power negative 6, and this will give us the answer of 2 multiplied by 10 to the power negative 3, and we can see that it is right here, option D. So it's pretty straightforward. Two charged plates are at a distance d from each other with a potential difference of delta V. What is the magnitude of the electrical field between the plates? Let's see what choices we have. So we want to find the relationship between the electrical field and the potential difference. Actually, it's pretty straightforward. We know that the potential difference is equal to the electrical field multiplied by the distance, right? So the electrical field, if we divide both sides by D, the electrical field will be equal to delta V divided by D, which is choice B. How much potential energy is needed to move a positive charge of magnitude Q from the negative plate to the positive plate? Okay, and we have these. We can say that the potential energy is equal to the potential difference multiplied by the charge. Okay, so it's pretty straightforward. The answer is going to be delta V multiplied by Q, and we know it's right here. So we solved some questions about potential energy and potential difference. Stay tuned for the next videos where we will be talking about simple circuits.